So what's next for this project?
The wires that we formed were all done by hand, which limited the length of the resulting wires and also limited the reproducibility. So ideally, it would be preferable to use machinery to do the elongation, and that's something we're currently looking at. One of the important things that I'd like to point out is that this work was all done by really excellent graduate students and also collaboration with some of my colleagues in my department. I'm really thankful for all their efforts.
Fantastic. Well, to finish then, I'd like to ask, as always, in your opinion, what are the hot topics in material science right now?
Well, I'm going to show off some that I'm a little bit partial here because it's an area that I'm personally interested in, but I am partial to soft materials, and I think there's genuinely a lot of interest in this topic right now for a number of reasons. Where I live in the Research Triangle in North Carolina, there's a lot of interest at the universities that are in this region. And I'll just give you an example. In our group, we're interested in soft conductors and actuators, including the liquid metals we just talked about. The human body provides one source of inspiration for this work, since the body has, for example, nerve networks, memory, sensors, and many other complex mechanisms that are built entirely from soft materials. And there really are very few man-made analogs that can mimic what our body can do using soft materials. Yet it would be interesting to make systems like these to create new devices that have the functionality that we find in the body built entirely from synthetic materials to make interesting devices.
Fantastic. Well, thank you very much for joining us today. It's been a pleasure talking to you.
Oh, it's been great. Thanks a lot for having me.